Continuing 4.4, hopefully you've practiced your understanding of each individual transformation and that meaning behind P, Q, and A, because now we're going to start combining them together. So in our first example here, we are given the equation y equals 2x squared plus 2. So before we go any further, what I'd like you to do is just identify what of those variables A, P, and Q are showing up. A is 2, and also Q is 2. There is no constant attached to x inside the square. It's just x squared. That means that P is 0. So already I can extrapolate some information about this. Specifically, I know my vertex is going to be at 0, 2, because remember, in general, our vertex is at P, Q. I can also look at my value of A. It's positive, which means my quadratic equation, my parabola, is then opening up. That means I'm going to have a minimum, and it's at my y value of my vertex, so y equals 2. My axis of symmetry runs through my vertex, and so that is x equals 0. My domain I can also already imply because it's the same for all quadratic equations. It is negative infinity to positive infinity. My range goes from my minimum upward, so I'm going from 2 and up. So I've already got a pretty good sense of most of these values. I even actually know my y-intercept because my x value is 0 for my vertex. My y value also happens to be my y-intercept. So that is going to be positive 2. Got some funny stuff going on here. 2. There we go. So from here, I can really get a good sense of what my graph is going to look like. My point is not at 0, 0 though, so whereas I want to put my vertex at 0, 0, that is no longer an option. So instead, I'm going to put it in my scale, and it's 0, 2 on my y-axis. From here, we're going to figure out our other points. So usually 1 squared is 1, but that's multiplied by 2, so it's going to be 2. Then we're going to add 2 to that, according to my equation, and so my next point is actually here, and that's where we're getting that vertical stretch happening. Sorry, this is not very nice. Bear with the ugly parabola, and remember that it should be relatively smooth coming in there. So the only thing I'm left with in terms of my characteristics that I need to identify is my x-intercepts. Because it is opening upward and my vertex is above my x-axis, I actually don't have any. So I say no real roots. So in this particular case, this equation would result, if we looked at it as if it was in general form, and we tried to use our discriminant, we would get a negative value. No real roots. Looking at B, again, the first thing you want to do is just identify your different values. So A is 1 because there's nothing out in front of my x squared term. P in this case is actually going to be negative 2. Remember to switch the sign. And Q is going to be negative 1. So again, I can start filling out a ton of my characteristics without even graphing them. So my vertex is the coordinate points negative 2 and negative 1. My axis of symmetry goes through my vertex, so it's at x equals negative 2. And my minimum, because A is still positive, is going to be at y equals -1. My range then is still opening upward, so I've got a minimum of -1 to positive infinity. Domain, as usual, is -infinity to positive infinity. The only time we see a restriction on that domain is if we're talking about a word problem, because then not all values are acceptable. Like when we talk about measurement, we don't usually talk about negatives when we're measuring. So from here, because I do have that p value that's part of my vertex, I can no longer imply that my y-intercept is equal to that constant at the end. So this was, I kind of alluded to in the previous video, but we can start graphing and we can see if we can figure it out from there. If it's not blatantly obvious on our graph, then what we'll do is we will solve for it. So my vertex is at -2 and -1, so -2, -1. My point there. It is not stretched vertically or horizontally. So if you've already started noticing a pattern in our quadratic, you can start putting on points following that pattern. Otherwise, we can talk about plugging in values. So -1, if we plug that in for x, we've got -1 plus 2 is +1. So +1 squared is 1. 1 for this whole term minus 1 is 0. So I'm going to get my points here and here. Because again, make sure we've got that symmetry still holding true. If I plug in 0, I've got 0 plus 2 is 2. Squared is 4. 4 minus 1 is 3. And so luckily, on this particular graph, I do get a nice y-intercept. And I've got nice x-intercepts. And again, try and smooth that out. My eraser isn't working on my stylus right now, which is making this particularly messy. There we go. So from here, I can answer my last two pieces of information. My x-intercepts are at positive, nope, not positive anything, are at -1 and -3. My y-intercept is at +3. There. And that is my graph in a nutshell for that equation. So we're going to continue this pattern, but for C, we've actually got all three pieces of our transformation possibility. So Q, and it doesn't really matter which way we analyze them in what order. Q is +2, P is -3. Again, remember to switch the sign inside that bracket. And A is now -2. So the big thing here is that negative is going to really throw a wrench in things in comparison to before. So my vertex, well, I still look in, say it's PQ, so -3, 2. But because A is negative, that means that my parabola is opening downward. This means that I have a maximum instead. Still at my vertex, so y equals 2. My axis of symmetry doesn't change, no matter if it's opening upward or opening downward. So I've got axis of symmetry at x equals -3 going through my vertex. My domain also stays -infinity to positive infinity. Any x value can be plugged into this equation. But my range is going to be a little bit different. Instead, my minimum doesn't exist. I have no minimum, so it can keep going forever in the downward direction, but it does have a cap at the top. So again, if we're wanting to write this in interval notation, how it would work would be y is an element of the reals, but y now has to be less than or equal to 2. So that's the only change. It's kind of a variation on the same idea. We just need to switch that less than or equal to from a greater than or equal to. Now that we've got all those characteristics, we can start plugging in. Label your scale and your axes, and we can get going. vertex is at -3, +2. So I see it's in quadrant 2. This is the first time we're talking about that. We've got quadrant 1, 2, 3, and 4. With how that breaks down, and this is going to come into play when we start getting into our trig unit. It's good to kind of think about now. So our vertex is in quadrant 2, so it's above the x-axis, but our parabola is going to be opening downward, which means it is going to cross the x-axis. So I do know that I have some x-intercepts coming. So unlike the example A, where we had no real roots because my vertex was kind of between quadrants 1 and 2, now I know for sure that I'm going to have some x-intercepts. So I'm going to keep going. Again, if you've already kind of figured out the pattern of how 2 is going to impact your graph, that multiplying 2, that's great. I'm going to kind of show you another way to think about it instead of just always having to plug and chug. So we've got our x values, and I'm going to choose them very specifically. Then we've got our parent function. So we've got f of x equals x squared. If we think about it as, sorry, let me erase that. Not f again, it's a different function. We introduce all of these separately. We can see kind of how our values vary. Finally, I'm not going to use I because I actually is a constant in math, so I'm going to jump to J. And we'll just do the negative and the 2 at the same time. So we're going to kind of work through this, starting with our regular, or we're going to extend so that we know that they're going to kind of match up with the graph that we finally want. So I'm going to start at probably -5, -4, -3, -2, -1, 0, 1, 2, 3. So -5 squared would be 25. 4 squared is 16, 9, 4, 1, 0, 1, 4, 9. Moving forward, if we added 3 to our x value before squaring it, so -5 plus 3 would then be -2, so that shifts all my values a little bit. So now this becomes, or -2, sorry. So this, we're basically shifting down 3 and filling it in from there. So my -2 value now becomes associated with -5. Now you can actually plug these in and check to see that I'm not lying. I recommend you do that so that you actually believe me and you're not just rotely being a robot or anything like that. 16, 25, and I'm following the symmetry of this side. That's how I'm getting these values in 36. And just remember 3 plus 3 would be 6 squared is 36 is another way of thinking about it. Okay, now we've got the same function here, but we're adding 2. So we're going to add 2 to this output value that we already had. So it's not going to be 4 anymore. It's going to be 6. 3, 2, 3, 6, 11, 18, 27, and 38. So we've now shifted all of these upward by 2. And that's the impact of that Q value. Shift our graph upward. But then we get J, and it's like, okay, that's great, except this is going to be a little bit different. Now, we can kind of ignore this section here because that -2 comes into play before we add 2. So make sure we note that bed mass says we do this before we do this. Okay, so again, maybe that would have been better. Multiply before we add. So we go back to this original one, 4. 4 times -2 is -8. Then add 2 is actually -6. 1 times -2 is -2, plus 2 is 0. Okay, so this one becomes irrelevant, because although we kind of saw that flip negative, that was just a coincidence. And it does help us keep track of where our vertex is still. This is where we get our point of inflection around a vertex and symmetry on either side, so that should work out to be the same. So now we've got -2 times 0 is 0, plus 2. Okay. And then we've got some symmetry going on here, so 0 and -6. Alternately, we've got 9 times -2 is -18, plus 2 is -16. Okay, so again, notice that these two values are not matching. Okay, so doing just the shift up versus the flip and then shift up means that we're going to get different y values. And we've got 16 times -2 is -32, plus 2 is -30, and it's going to keep going. I know my graph is going to not extend that far, so I'm not going to continue. So now I've got some new values. I've got x is -5, y is -6, and I can plot that here. X is -5, so 3, -4, -5. Y is -6, so -3, -4, -5, -6. And I've got a point there. And at -4, reading across, -4 is at 0. So good news. I also have some information in terms of what to expect for my x-intercepts, -4 and 0. And then I can continue my symmetry on the other side, and we saw that in our table of values as well. From here, we want to draw our parabola. So I know that was a very convoluted way of getting here. You by no means have to do that. What I really wanted you to focus on when we do those table of values like that is the impact of each shift can be added in individually. If I had done this separately and done the multiply then the add, we would have been able to literally track those changes and how they were able to be added in one at a time, and your table of values kind of takes on a new meaning. We see those properties that we talked about in our previous lesson about A and its impacts, P and its impacts, and Q and its impacts, right in our values instead of just doing a visual comparison like we did in the activity in our previous lesson. So we continue on. We've got a couple more examples. Okay, I'm going to look at D right now. In this case, we've got A is a fraction, so we know that's going to be compressed, but it's still opening upwards because it's positive. P is now +2 because we switched that sign, and Q is -3. So we look at this and we're like, okay, great. So first of all, our vertex is going to be at +2 and -3, which is down here. It's opening upwards, so my vertex is in quadrant 4. And so that means, and it's opening upward, which means I'm going to have some x-intercepts, so good news. I can also start filling in these values. So 2 and -3 is my vertex. It's opening upwards since A is positive, so I have a minimum. at y equals -3. My axis of symmetry is at x equals +2. My domain still is -infinity to +infinity since we have no parameters in a word problem. My range then goes back to normal, where it's a minimum of -3 and forever extending upwards. From here, you can plug and chug, fill in your table of values. You can also kind of follow our pattern. Usually our parent function goes over 1 up 1, because 1 squared is 1. But because it's multiplied by a half, that shift up is actually going to be a half. Now I'd go from here. 2 squared is usually 4, so up by 4. But since I'm halving that, it's actually going to be -1. I'm only going to go up by 2. My third one, 3 squared, is usually 9. But 9 halved is actually going to be 4.5. So I'm going to go up 4.5. And then 5 squared is 25. Half of 25 is 12.5. So I'm going to go over, then up 4, 5, 6, 7, 8, 9, 10. And it's just a little bit off my graph, so I'm not going to plot that. Oh, I forgot to add my scales in, so let's do that now. Don't forget them. Always double check your graphs that you've got all this information on there. I've got all my points. That is super ugly. That way. My apologies, I'm using a different stylus today. Okay, make sure it's kind of curvy in and around our vertex. Try and make it sort of symmetrical. And my x-intercepts are not a defined value here, but my y-intercept is, so I can say that that is -1. My x-intercepts I would need to solve for. How do we do that? We need to say that y equals 0, and then solve for x. So we've got half, and then x, not plus, -2 squared plus 3. So I'm going to move that 3 over. -3 equals a half x minus 2 squared. I'm going to multiply by 2, because 2 halves makes a whole, so cancel that out. But I do that on both sides. And I've got x minus 2 squared equals -6. Now I'm going to take the square root of this. Can I do that? No. What's the problem here? I've made a mistake. And so I'm going to have to fix it. So where did I make my mistake? Well, if I look at my graph, I am 100% confident that I'm definitely going to have x-intercepts. So my mistake is somewhere in here. Specifically, right there. I accidentally switched my sign of my q value, so this is incorrect. I'm going to do the same process, just with the right sign, so that I can actually get an answer, or 2 answers, because I have 2 intercepts. So now that gives me 3 equals a half x minus 2 squared. Multiply by 2 again to get rid of my half. Again, I'm slowly peeling away the layers to get to that x. Okay, to get rid of a square, we take the square root. But when we introduce a square root into an equation, it can be positive or negative. Now, the reason that this happens is that you can take 3 squared, and that gives you 9. But you could also take -3 squared, and that also gives you 9. So because we've got the potential for either the positive or negative values, we don't know which one it was to start with, we have to account for both. This means that x minus 2 could have been positive or negative square root 6. So when I add 2 to both sides, to cancel this out, my final answer is 2 plus or minus the square root of 6. And those are my x-intercepts. So when I go back over here, that's exactly what I can list. I can list 2 plus the square root of 6 and 2 minus the square root of 6. Now I've got all of my characteristics here. So it's always helpful, even if you aren't actually asked to graph the function, but you are asked for those x-intercepts, it's a good idea to even just take a second and sketch it out so that you can get a sense of, did I do something arithmetically wrong, or did I get it right when I'm saying that there's no roots? So I strongly recommend that. So we write the equation of the quadratic functions given properties of their graph. So this is a great scenario where this has to occur. So we are given, and I just like to have a little sketch, our vertex is at 2 and 1, so somewhere here, and I've got a point that's at 3 and 4. So my quadratic is going to have, my parabola is going to look something like that. So it's just a sketch to help me picture what's going on. I know from this that we can go y equals a, but I don't know what a is, and then plug in my values for p and q. It's going to be x minus 2, don't forget it's the switch of signs, squared, plus 1. But I need to solve for that a value. I need to make sure that I know if it's being stretched or compressed, because I have an inkling that it is. If we went from 2 and 1 to 4 instead of, so that's a change of 3 instead of the usual change of 1. So I'm going to double check by plugging this point in. So 3, remember x is always listed before y, so we've got 4 equals a times 3 minus 2 squared plus 1. We can move that 1 right away, and we can also simplify what's in the brackets. So we've got 3 equals a times 3 minus 2 is 1 squared. 1 squared is 1, divided over, so we're left with a equals 3. Now that I know that, actually I'm just going to undo that because it's not my final answer. I want to write the equation. That's what my question was actually asking. I'm going to write y equals 3 x minus 2 squared plus 1. And I just want to double check that that a makes sense. It's a stretch because it's a bigger change than we usually expect of that over 1 up 1 kind of pattern. It's also still opening upwards, so my a value should be positive. I'm feeling pretty good about this, so that is my final answer. Axis of symmetry is -1, and we've got 2 points. What do you notice about one of those points? It is our y-intercept. So, good news. We have our x value of our vertex. So that is also my p value. P equals -1. My vertex is at -1 and something. I'm going to have to figure that part out. But I do know my other 2 points. So here's where it gets a little interesting. So I've got a thus far, x plus 1, because again remember p switches signs, squared, plus q. So I know my axis of symmetry is here. I know that at 0 and positive 3, about that point, and at negative 3, I'm at positive 9. So that gives me a couple other points. That gives me, if I go 1 over in this direction, I'm at positive 3. If I go 1 over in this direction, I'm at positive 3 as well. So I've already got a sense that my vertex might actually end up being above my x-axis. So it's going to look something like this. That would be my guess. Because the difference between 3 and 9, I'm moving over 2. Usually it's a substantial change. It's smaller than normal now. So from here, we need to decide what to do next. Because we don't know A and we don't know Q, what we're going to have to do is use these points. We're going to create a system of equations that we're then going to have to work with. So this is something that harkens back to our grade 10 math days. So equation number 1, we're going to use A is 0 and 3, and we're going to plug that in. So that lets us say that y is 3, it's going to be A times, and then x is 0 plus 1 squared plus q. 1 squared is 1, so my actual equation is going to be 3 equals A plus q. My second equation is going to be using B. I'm going to plug that into here. And so I get 9 equals A times negative 3 plus 1 squared plus q. So 9 is equal to negative 3 plus 1 is 2. Squared is 4, so 4A plus q. We can then take these two equations and add or subtract or substitute, whatever your preference is. I like adding and subtracting personally. So I'm going to take 9 equals 4A plus q. I'm going to subtract 3 equals A plus q so that I can eliminate q. And I'm going to get 6 equals 3A, so A is 2. Once I know that A is 2, I can go back to either one of these equations and solve for q, or I can even go back to my original equation over here. So if A is 2 and it needs to add to be 3, then q has to be positive 1. And so my final answer is going to be y equals 2x plus 1 squared plus 1. And that will be my final answer.